Hello, my name is Robert, and welcome to my adventure. This isn't really an adventure so much as answering questions I've gotten about the solar setup on my camper here. People ask about it because I talk about it a lot, you know, how I don't need to plug into shore power. So I thought I'd take a moment and walk you through it. So what I have is on the roof, I installed 4 200-watt solar panels. They're bifacial N-type. Bifacial means they can make power from either side of the panel, meaning if light hits the back side, you'll get some power from that. Nowhere near as much as the front, but you do get a little bit. Now, I have mounted them so close to the roof, there's only about 1.5 inch gap between the panel and the roof that I don't think I get much from it. Although the white roof does reflect some light, so I probably pick up a little bit. It's energy that would have been wasted if I had had regular panels, so maybe there's something to it, but I wouldn't go out of your way to get bifacial in this application if it somehow cost you more. I got a really good deal on these, and I can tell you these 200-watt panels outperform their spec. I've seen on my Servo GX, the controller that kind of monitors the whole solar setup and the whole camper, over 1,200 watts on occasion coming down, which is just unbelievable. Now, that was ideal solar conditions. You know, it was a cool day, direct sun, no clouds. Every day, though, you know, every good solar day, I exceed the 800 watts claimed routinely, which is really great. Now, they're brand new, so over time, as efficiency goes down, of course, those numbers will come down. But for now, I am amazed. And the value, I forget, it was just over $300 for a 2-panel set. You can't beat that. I have installed them in what they call 2S 2P. Meaning 2 panels in series and then those series panels in parallel. That gets me to a 24-volt system, and which in reality runs closer to 50 volts because, you know, panels run higher than the rated voltage. I've seen 56 volts, I think, on the high end. And the reason I did that was, one, I wanted to reduce the current coming down from the roof, and I wanted it to be able to start putting power into the batteries sooner, when the sun's coming up and when it's going down, and also in non-ideal solar conditions, because as you know, the voltage of the panels has to be above the voltage of the battery to get current to flow. So if you do a 2S 2P, then you are above that threshold voltage sooner, so you can start to get power in. It works well for me. I like it. The biggest benefit, though, was reducing the current coming down, because under wiring them 12 volts all in series, I could have had, all in parallel, I could have had 70 amps potentially coming down from the roof. Now, I've run 8-gauge wire down from the roof with a temperature rating. I forget what the temperature rating on the insulation is. It's high. It's like 130, 140 degrees C. So it's a really good wire. So I wasn't super worried about, you know, potential of a fire or anything like that, but you have to design for it. So that's what I ended up doing, was I installed it for the original parallel install, and then I realized after I started to build it that I wanted series parallel, which is just a benefit because it drops the current down. I've only seen, I think the most I've seen is 20 amps, 21 amps coming down, which is not bad at all. That wire is massively overrated for that. So works well. Let's go inside and take a look at the controller, and I'll show you how the bits under the seat actually work. Let's take a look in here. So this is where the solar controllers and all the oily bits that make it work live. This being a truck camper, there's not a lot of room, so I had to kind of stick it where I could find room. And I know this is not where you want to install your solar stuff, right next to your water tank, but I really didn't have a choice. No, not really. I didn't have a choice, so it had to be there. And if you see above the solar controller, there's a metal plate there that will redirect the water should that hose leak. It'll put it on the floor and not down inside my expensive solar controller. So in here, it's all Victron. I am a huge supporter of Victron. They make amazing stuff, and it just works. So we have our solar controller. It's an MPPT 150-100, so it can handle up to 150 volts at 100 amps, which is, again, hugely oversized for what I'm doing. But remember, when I bought this stuff, I was planning on doing 12 volts, not 24. I added the auxiliary display, which I'm not sure the camera can even see, which tells me that the voltage is 13.3 volts coming down, and it's at that's the output, sorry. 13.4 volts and 15 amps. So we're getting power down. That comes down into our distribution block here, which is the smart distribution block, although I don't use the smart features of it. I do have it wired up so that if I blow a fuse, those indicator lights do come on. So it's kind of cool, but it's a bit overkill. When I bought it, I didn't realize they made a dumb version that would have suited me better. Over here is my multiplus inverter. It's a 12 volt, 1200 watt. Now, why only 1200 watts? Well, first off, their 2000 watt inverter is a lot physically bigger, and as you can see, space is an issue, but also in this camper, I don't run a lot of AC. Pretty much it's just the refrigerator, the vacuum cleaner when I run it, and a few little auxiliaries. So I don't need more than 1200 watts. I've never pulled more than 800, and this handles it more than fine. So 1200 watts was the right answer for me. If there was anything that I would do again, maybe I would really try and find a way to get a 1200 in here, but it would be, I'm sorry, a 2000 in here, but it would be a heck of a squeeze, as you can see. So this is main power coming in from my battery bank, which you'll see in a moment, and it comes over, hits a disconnect, goes into the distribution board. The ground or the negative terminal for that system goes through a smart shunt, which tells me, how much power I'm using, which way it's going, and it outputs to my Serbo GX up here, which is an amazing little piece of kit. If you're going to build a solar setup, definitely worth the extra money to get one of those because it can do so much. So it comes out of this board and goes to the inverter, which we just alluded to, and you can see the power coming in from the solar setup. And then the DC bus, that's 8-gauge wire, again, more of the wire I got coming down from the roof. And then just some accessories there. That's mostly stuff to run, like the smart shunt and the servo, as I recall. So over here is a breaker protecting the solar panels coming down and also a way to shut them off. Then there's a physical switch to shut off the solar panels, because remember, breakers are not designed to be switches. People use them as such, and I'm guilty of it too, but they're not made to be cycled all the time. Now that said, how often do you cycle it? Not very often. But I installed a switch below it so I wouldn't have to cycle it. Next to it is the switch for the DC bus, so I can shut off the DC bus without dropping DC bus to the camper without dropping the whole solar setup for maintenance. And then above it is the DC distribution board. And this disconnect here is the main disconnect for the battery bank. Again, I don't want to use the breaker as a switch, so that's my disconnect for that. And then over here, which is hard to see, is the AC side. So I've got AC power coming down from the shore power protected with a breaker, and then I have 3 AC outputs, although only 2 are in use, going to the camper. That's their breaker protection. And what I did is I removed the factory distribution panel, which a lot of you are familiar with. I mean, pretty much everybody's RV has it, the little power supply that's in there in your AC portion, and it goes to a DC fuse box and whatnot. I cut all that out and wired it in down here and just put a blanking plate. And it works good, and it made it easy to cut over without having to rewire the whole camper. I would definitely recommend that. The only thing is, it would be a pain to pull all this out and go back to the old system if I ever sold it or anything. So this is probably in here to stay. So it's a pretty neat setup. It stays cool. I was really worried about it being hot, and I actually installed a temperature sensor in the roof of this compartment to monitor the temperature real time through the servo, so I would know if it's overheating, because I had a plan to install some vents and auxiliary cooling fans, but I'll tell you, so far I haven't needed it. Even on these 95-degree days, it's only a few degrees above the ambient in the camper. So thus far, I have had no issues, and I'm not going to install that stuff until I do. I did put a work light in here that's on a magnetic switch that light turns on when I open the door, because it's hard enough working in here. Imagine doing it while holding the flashlight. Not so much fun. Let's check out where the batteries are. So the batteries are in a bay on the opposite side of the room from where the solar is. Not ideal, but again, due to space constraints, this is how it had to be. there are cables that run through this wire chase I made here that connect the batteries to the solar and also some auxiliary electrical into the back of the camper that wasn't always there. So these are my batteries. These are LiTime 320 amp hour lithium iron phosphate batteries. These work extremely well. I have it wired up with 2/0 gauge welding cable. I forget what the thermal temperature rating is on the insulation, but it's very high. I've had no issues with heating on these cables. The most I've ever seen drawn out of here, I think, was 40 amps, maybe 50 amps when I was doing like a hard load test. The cables are rated, I want to say 300. They're fused on top of the terminals at 250 and on the positive terminals, and I think the BMS shuts it off at 200 or 225. So it's a pretty robust system. The pieces of wood you see above the batteries are just there to hold another piece of wood, like a piece of plywood, so I don't give up this whole space. I need some storage because it's a truck camper and there ain't a lot of room. But those pop out quick, and then there's a strap that holds them in so I can pull them out come fall and winter, because we all know that lithium likes to sleep in the house with you. So they're easy to take in and out. The smart battery feature on these is both a blessing and a curse. Blessing in that I can see what they're doing, what the BMS is doing, how much current in and out through an app on my phone, and it's good information. The downside is they're too clever by half, because what they do is, for reasons I don't fully understand, it'll discharge one battery and the other one, the BMS, will keep it off. So one will go down to like 50% and the other one's at 100. And then all of a sudden, the other one will cut in and come online, take the load from the first one, and it'll actually discharge into the one that was originally online about 8% of capacity. And then the one that is being charged goes, okay, I'm not supposed to be charging, and it stops. I don't know why. I know other people have commented on this, and it's more of a nuisance than anything at this time, but I just wanted to make you aware of it. I know that, what's his name, Will Powers, or the solar guru there, you know, he has an issue with that, and he says don't buy the smart version of this, although I bought it not knowing there was an issue with the smart version. That said, is it really a problem? I don't know. It's almost nice to be able to go into an app and turn off one battery and run on the other, to know that you have a reserve, and then just switch them anytime you want. So I guess it's kind of a 6 of one, half dozen of another. Is it an issue that kind of annoys me? Yeah. Is it something that affects the operation of my system? Not at all. So I'm hoping they'll come out with a patch for the BMSs that'll take care of that. Here's one of the cool things about this system. So I have installed the display that plugs into the servo, and I can see real time while I'm sitting here what my solar is doing, what my water is at, what my propane is at. So looking at this display, you can see that my batteries are at 85%. They charge to 95% during the day. The freshwater tank is at 95%, and the propane's at 40%. Now that propane number, it's more of a rough estimation versus an actual value. I find it's not as accurate as I would like it to be. The freshwater tank is accurate. This camper didn't have a level indicator when it was new. I installed one, and it took a little bit of fiddling to get it to read right, but it works well now. And I can see my solar coming down right now is 257 watts. My AC load is 170 watts because I'm running the fridge on AC, and then my DC load is what? It's bouncing around between 20 and 40. Pretty much on the DC load, what's running right now is the control power for the solar system and the Starlink on the roof, which is something I'll go into in another video, how I got that set up, because I did a little bit of a non-standard install. But what's cool about this is all the different ways to see it. So here's more of a detailed power breakdown. So I can see, again, the same information, but with more detail, how many amps are moving around, how many watts that equates to, battery state of charge. The little animations show you which way power is flowing at any given minute, which is kind of neat, so you can see where your load is going. And then come over here to temperature page, and so I have sensors all through the camper. A little bit nerdy for a camper of this size. Well, okay, not a little bit, a lot. But I can see the battery bay, the fridge temperature, which is higher than I'd like it to be. That's an ongoing issue. electric bay temperature inside the camper and outside the camper. And this is really neat because through the Serbo, because it's connected to Starlink, I can access it through a computer or my phone, and I can actually see all this data anywhere I have internet. So I can monitor it. If there's a problem, I set alarms and I'll get notifications that I need to go deal with, which is pretty handy. Then you go over here to the tanks page, and again, more detail. You can see the water tank and the propane tank. And notifications, these are just alarms. I haven't found a way to delete these. Once they're in there, they seem to be in there forever, but it's all just either the Starlink got turned off or shore power was turned off. I don't know why it sets an alarm when you turn off shore power, because it's kind of a normal thing, but it does. And then just your settings page. What's cool about the Serbo is you can actually have relays that you can come in here and command to turn on and off, either remotely, or you can set automation that will turn it on and off for you, which is kind of neat. So I was going to use that if I was having a problem with the temperature in the electric bay. I would rig up a fan that above a certain temperature threshold, it would come on and exhaust into the camper. And it's all native to the Serbo. I didn't have to rig up any relays or anything like that. It has a relay, I believe it can handle up to 10 amps, but don't quote me on that, which is quite a bit. You know, those little fans only draw an amp or two, so more than enough. Pretty neat setup. Talking about the Serbo and how it goes through the Starlink onto the Victron portal. When I'm going down the road, I have a tablet set up when I'm going on long trips. And yes, I realize this is turbo nerdy, but I can see what's going on with the solar system in the back. Power coming down, power going out, battery status, the whole 9 yards, and all of my temperatures. And even predicted outputs based on what Victron's weather says the solar, you know, theoretical maximum solar you can get versus what you actually get. I don't really look at that part going down the road, but I just reference this. So if something starts going on with the fridge or the batteries or something like that, I know about it. My alarms will show here and I can pull over and take action. I also use this as a second GPS. If driving across country, I find it's nice to have two GPSs. One for your final destination for the day and one for your next like waypoint. Also, if a GPS goes down when you're in traffic, which has happened to me, I have another, way to another GPS up and running until I can get the other one back up. It's a real pain, especially with the Android Auto app in this GM truck. It was one of the early implementations, there we go, of Android Auto. And while it's really great, it can be a little buggy at times. And it's always when you're going through like New York or Cincinnati or something like that it screws up. So, and then kind of an aside, I'm also a ham radio operator, so I have a an Yaesu in here that I monitor 11 meters or CB, the truckers, because if you're coming into traffic, they will tell you what lane to be in, what to watch out for, what's going on up ahead. They're not telling you, they're telling each other, and you just got to listen. I don't really talk to them because, what am I going to add to the conversation? But it is nice to be able to listen. And then when it's just me and I'm on a long, leg, I'll jump on 20 meters or 40 meters and get some contacts in my logbook just for fun. So I thought that this could be helpful for you guys to actually see and know that you can also access it on your phone and on a PC. So even when I'm at work, I'll often have a screen up with this open just so I can see what my camper's doing at home, so I know if there's any issues or anything like that. I'll know about it before I come home and find a smoking pile of rubble in my yard. I don't know what I'd do about it, I guess, but I'd at least know that it's on fire. One of the challenges with putting the solar panels on the roof is this is a pop-up truck camper. Pops up about 2 feet, which there are pros and cons to, which I'll go into in another video. But something that was a bit of a challenge was getting the power down from the roof to the solar controllers through a joint that moves. And the camper had this flex, that's just a piece of canvas, all it is, where they ran the wiring for the lights that go around the top of the camper when you're going down the road. So what I did was I fished down through my solar power wires, and there's also Starlink wire in there as well, because the Starlink is mounted on a magnetic base on the roof, which is something I'll go into in another video. But I had to figure out how I could do this in such a way that it wouldn't chafe. So I ended up running it through this factory installed, I don't know, wire chase, if you want to call it that. It's pretty hokey, but it works. It was a bit of a pain pulling the wire through there. And you can see it goes into here, and then it goes into this cabinet behind the fridge, which is a good time pulling the wire through there. 8 gauge, oh yeah. Behind the stove, over the top of the hot water heater, around the back of the sink, down through where the old power distribution panel was, and then into the solar controller area down there. It was a pain to run. I say pain, it's a relative term. I mean, 8 gauge wire isn't super flexible, and that insulation is pretty robust, so it made it a little bit hard to work with. If it would have been a higher gauge wire, it would have been easier to pull, but like I said, I wanted the performance of the 8 gauge. Now it's in though, I don't have to worry about it. It's very robust, it's not gonna chafe. I've got it secured in such a way that it doesn't chafe, and thus far it's worked out well. And I even go in there periodically and take a look at it to make sure it's not chafing. And so far, I've been on, I don't know, this is my 12th trip that I've been on with this camper, probably the 11th with the solar installed, and thus far no issues. And the top has been up and down countless times since then. So fingers crossed. That's my solar setup. If you have any questions or comments, please leave them down below. Let me know, if you're running solar, how is your system wired? Are you doing parallel and series? Are you doing one or the other? If so, why? What made you choose that route? Did your camper come that way, or you wanted series because you wanted the higher voltage so you could use smaller wire? Let me know. I'd be very interested to hear from people who are actually doing it. Or if you got a plan, you want to do a solar setup, what are you planning? Okay, I think we can all benefit from sharing this information before we start cutting wire and buying parts. You know, what are other guys doing? It's a big help. So thanks for watching this video. I hope you found it somewhat informative, and I hope to see you back soon. I got to do the YouTube plug, right? Please like, share, and subscribe. I don't get paid for this, and it's probably good, right? Because you probably got what you paid for out of it. But the likes and the comments and the subscribes are my paycheck, and I get a huge smile on my face every time I get a new subscriber or a new a like or something like that. I mean, hey, I'm not a professional. I'm a guy who boils water for a living in a in a factory. So this is just a hobby I do, and maybe it's a way to justify the money I've spent on this camper. I don't know. I suppose I can't justify it to my wife, no matter what explanation I use, whatever metric I use. She's not going to buy it, but that's okay. She's very patient and understanding, and I'm grateful for it. So thanks for watching, and Gracie and I hope you have an outstanding day, and we'll see you in the next one. So I'm Robert, and this was my Not Adventure.